We found a cool math problem. We're asked to find the line of intersection between this plane that's got x, y, and z, and then we have the cylinder that's x squared plus y squared. And at first, we might be tempted to set z equal to 0, so that way we're left with the 3x plus 3y, and then we can try to solve maybe for x and y and put these together and see what happens. But the problem is we're not going to find any point of intersection. That's not going to work because, unfortunately, this is in 2D, but if we were to move this to 3D, we can actually find a point of intersection. So what we're going to do is we're going to turn this into a 3D system. We're going to say that x equals r cosine t, and y equals r sine t, and then z would be equal to z. And so if we were to do this, then we can see that r is equal to 3. And we can plug that in here and say x equals 3 cosine t, y equals 3 sine t. And then from here, we're going to plug these into the plane, because now we can solve for maybe z over here. All right, so we're just going to say that 3x plus 3y plus 5z equals 1. But let's say that 5z was equal to 1 minus 3x plus 3y, or 3x minus 3y. And then we'll say z equals 1/5 minus 3/5 x minus 3/5 y. And then we're going to use these coordinates here. So we're going to say z equals 1/5 minus 3/5, and then 3 cosine t, and then minus 3 over 5 times 3 sine t. And then we're going to say that, yeah, I mean, this is kind of now the new equation we can use. So basically we have our final equation of the line of intersection is just going to be x equals 3 cosine t, y equals 3 sine t, and z equals 1/5 minus 3/5, well, you can multiply this out, so we could say 9 over 5. So minus 9 over 5 cosine t, and then minus 9 over 5 sine t. And that's it. That's the point of intersection. So all we need to do is move it from 2D to 3D, and now we have the perfect line that intersects for these two coordinates. It's interesting.